Hey everyone, it's Justin again. We've reached the end of this unit, so in this video, we're going to wind down by using what we've learned to expand our knowledge even further to systems with even more variables. Bailey is 20 years older than Abby, Kaylee is 3 times as old as Abby, and Bailey and Kaylee are twins. How old is Abby? Obviously, the part we don't know yet is Abby, Bailey, and Kaylee's ages. We do, however, know some relationships between them. We know that Bailey's age is 20 more than Abby's. We know that Kaylee's age is 3 times Abby's. And we know Bailey and Kaylee are exactly the same age. Typically, we choose one method to do this problem, but let's have some fun with it and solve using all 3 methods. Let's use the substitution method first. Substitution with more than 2 variables is kind of fun. Here's why. If we choose the top equation to start with, we can then use the bottom equation to say B is the same as C, and use the middle equation to say C is the same as 3A. Now we have an equation with only one variable, so we could solve. But we could also start with the middle equation, use the bottom equation to replace C with B, then use the first equation to substitute A plus 20 in the place of B. Now we'd be ready to solve. Or we could start with the bottom equation, use the top equation to substitute for B, and use the middle equation to substitute for C, and yet again, there's a solvable equation. The point here is, it doesn't matter how we go about using the substitution method, because we always end up at the same place. A plus 20 equals 3A. And when we solve that, we get that Abby is 10 years old. What about the elimination method? The process is still the same. Eliminate all but one variable, then solve for it. So we'll start by moving all the variables to the left side. That's better, except each equation is missing a variable. Remember, they aren't actually missing. They've just been zeroed out. So let's make them visible. There we go. Now this looks like a proper elimination problem. Let's get rid of those first few steps so now that we've got it set up the way that we want it. Okay. So now we need to combine these 3 equations down to a single equation with a single variable. We'll do this by combining 2 equations at a time. Do we have any eliminating terms at this point? Sure do. These 2 equations here will eliminate. So when we combine these 2 equations, we get an equation with 0 c's. Since neither equation has c's anymore, we can let them be invisible again. Now it just looks like a regular 2-variable system. So what do we do next? If we multiply either equation by -1, the b terms will be set up to eliminate. Now we just combine these equations, then divide by 2, and we get that Abby's age is 10. But we already knew that because that's the same answer we got from the substitution method. Let's rewind again and see how it would look if we wanted to solve by graphing. Usually graphing is the easiest method, but it becomes much harder with 3 variables. A graph can only have 2. So first we have to find some way to get rid of the 3rd variable. The secret is, we've actually seen a few ways to do it already. When we were using the substitution method, our substitutions resulted in 2 different equations using the variables C and A, as well as 2 equations using B and A. While using the elimination method, we eliminated C and got 2 equations with just B and A. We can graph any of these 2 variable systems to get a solution. Just change one variable to X and the other to Y. The graphs come out like this. Notice anything? The graph is the same no matter what. But in order to get to this point where we could graph, we had to also use either the substitution or elimination method to get rid of one of the variables. That's why graphing is so hard to use on systems with more than 2 variables. You have to use one of the other methods first just to get it down to 2 variables before you can graph. We've solved this problem with all 3 methods now, so what's the answer? With every method, we found out that Abby's age, is 10 years old. Next, Matt is 5 years older than twice Tom's age, and Dave is 10 years older than Matt and 3 times Tom's age. How old is Dave? I'll allow you to try this last example on your own, but I'll give you a little guidance. The answer. Pause now and attempt the problem on your own, then unpause when you think you have it. Ready? Okay. The answer is that Dave is 45 years old. Did you get it? If not, here's some tips. First, here are the equations. If you want to use the substitution method, start with the middle equation so you can use the others to substitute for D and M. If you want to use elimination, after getting everything lined up, the M terms should be ready to eliminate. If you wanted a challenge and chose to do it with the graphing method, use the substitution method to replace one of the variables so that there will be only 2 remaining. Logic puzzles get harder the more unknown information there is, but finally solving a hard puzzle is what makes it so much fun. If you can master these types of problems, then you've mastered systems.